4.5, number 232. F of x is x plus sine 2x over the interval negative pi on 2 to pi on 2. First derivative test, f prime of x equals 1 plus 2 cos 2x, that's equal to 0 or undefined. Define the critical values of the original function. But there's no place where this is undefined, so therefore we're only worried about equals to 0. So we get that cos 2x will equal negative 1/2. Okay? So cos 2x equals negative 1/2. Therefore, the reference angle that will help us get the solution here, the reference angle, is the one that would make the angle from the first quadrant that would make cos equal to 1/2. So we know that cos of pi on 3 is going to give us a value of 1/2. So the reference angle is pi on 3. And since the cos function is producing a negative value here, the quadrant we might be in is 2 of 4. So it's going to be 2 and 3, right? Quadrant 2 and 3 is where the cos function is a negative result. All right, so that gives us almost all we need. Perhaps a picture will help just a little bit. A picture is not totally necessary, but it does aid immensely in these types of problems. So if we're in quadrants 2 or 3 with a reference angle of pi on 3, so it should be up here, like something like this. Right. So this is a reference angle of pi on 3. Again, a reference angle, not the actual angle measured over here, but a reference angle. And in the third quadrant, the same thing. Right, a reference angle right here of pi on 3. So what are the actual angle values? Well, first of all, let's figure out again what interval we're in. We said it was negative pi on 2, right? Negative pi on 2 to pi on 2. So I'm really just looking from here, right? Negative pi on 2 to pi on 2. I'm really looking from here to here, right? Negative pi on 2 to pi on 2. So really, it looks like the moment I have no solutions. Right, I have no critical values, but we have to remember this is cos of 2x, it's not cos of x. So this is just an initial setup to help us get the value of x. Right? So right now, the actual angle measure here is 2 pi on 3. Right? So we have that 2x, not just x, but 2x could be a value like 2 pi on 3. Right? And if it went a little bit further, it would be what? 2 more pi's on 3 later. It would be 4 pi on 3, right? Another pi on 3, another pi on 3, and would get us all the way around to here. There's 4 pi on 3. And you just keep going. The next one would be all the way around. So 2 pi plus another 2 pi on 3 would be 8 pi on 3. And so forth, 8 pi on 3, and then another 2 pi on 3 would be 10 pi on 3, and so forth. You could keep writing them out if you needed to. We don't need that many, probably. Okay, so that's going in the positive direction. Going in the negative direction, 2x could also be interpreted as, measuring this way, negative 2 pi on 3, and then moving further, negative 4 pi on 3. And it's going to be the exact same values, but in the negative, which makes sense because cos is an even function. So negative 4 pi on 3, negative 8 pi on 3, negative 10 pi on 3, and so forth. If we need more, we can always get more. Now we'll just divide by 2 to get the actual x values here. So we'll get x equals, dividing by 2, we'll get pi on 3, 2 pi on 3, 4 pi on 3, and 5 pi on 3. All right, we divide by 2. Down here, you get x equals the negative of those exact same values. So negative pi on 3, negative 2 pi on 3, negative 4 pi on 3, negative 5 pi on 3, and going on forever. All right, so which of these is actually in this interval? Well, there's not very many, to be honest. There's really only negative pi on 3 and pi on 3. Okay, so a lot of this was a little bit superfluous, but just to get the idea of what you would do if the interval had been even larger. Okay, so now we see the only critical values in our interval, critical values within negative pi on 2 to pi on 2 are pi on 3 and negative pi on 3.